My name is Mark Coletti. I'm a computer scientist at the OakRidge National Laboratory, and I work for the Computer Science and Mathematics Division and the Learning Systems Group.
And I'm Robert Patton. I'm the group lead for the Learning Systems Group at OakRidge National Lab, and I'm in the Computer Science and Mathematics Division.
The award that we got this year was for Gremlin, which is a tool that we developed to find weaknesses in machine learning models. Why do we care about weaknesses in machine learning models? And the reason for that is that actually machine learning models are actually ubiquitous. They surround us. Anything from driving autonomous vehicles, you will have some kind of neural network, machine learning model driving that, to finding protein structures, to finding the forces in molecular dynamic simulations, to finding buildings and satellite imagery, and so on and so forth. So models all around us, and so it's very important that we actually have high fidelity models because problems with models can actually lead to harming people and also to significant loss of property as well. So it's very important to us to have the best models that we can get, and Gremlin can hopefully help with that.
Yeah, and what Gremlin does for us is it helps us to identify different scenarios or data sets that may be within the operating parameters of the neural network, but we're not necessarily trained for. And so what that does is help us identify where particular situations or data sets where the neural network may fail. Then that is information we can bring back to developers to help them either enhance the neural architecture or enhance the training data set or both.
One of the jokes I like to tell people is that the machine learner only knows what you tell it. And what do you tell it? You tell it what's in the training data. And oftentimes the training data doesn't tell the whole story. And it's those gaps in the story that actually turn out to be very harmful. So Gremlin can find those gaps in the story, and hopefully developers can then shore up those gaps and resume training of the model to actually improve the model quality.
Whereas a great example of that is many years ago where a lot of neural networks are being used for facial recognition, and people kind of discovered that if I want to make myself look better, it's some of the neural networks are trying to make people's skin lighter color for people with darker color skin. And so Gremlin is a tool that might have found the weakness like that to say, hey, your training data set may have been biased. Or the neural network was not designed correctly. And Gremlin is now a tool to help automate the process of finding those weaknesses that would give that feedback to the developers to say, hey, it needs to be improved in certain ways.
It might help to give sort of a concrete example of Gremlin. Gremlin actually came out of some autonomous vehicle research that we were doing. So you can imagine training a neural network to drive a car around. And on this one particular project, we were training a model to drive a car around in a virtual environment. That way you can crash the car as many times as you want, and you're only hurting electrons. You're not hurting actual vehicles, right? So imagine further that you're testing the car, a virtual car, and it's in front of a building that's blocking the sun. And then when it turns and makes a turn out into a road where the sun is striking the cameras of the car, it's temporarily blinded. And it's something that's probably happened to you as well. So in this particular case, you have two features, the position of the sun and where the car is located, that by themselves may not mean anything, but it's the combination of those features. Where is the sun? Where is the vehicle? That right there, that combination causes a problem. It's not obvious looking at the training data, but Gremlin can find that unique combination, identify that pathological scenario, and then what you can do is you can go back into the training data and add a lot of examples of where the car is coming out of the shadow into the sun at the right angle and causing problems, and then resume training of the model, so hopefully then it's able to compensate, be able to adapt to those specific scenarios.
Yeah, exactly. Gremlin is really geared towards really trying to improve the robustness of neural network behavior in operating circumstances.
I want to thank the committee for inviting us all out to come to this event. My first time here to the award ceremony, actually my first time to San Diego, so I appreciate the opportunity.
Yeah, and I thank the committee as well for the recognition of our technology that we've developed. We're extremely proud of the award, and we're looking forward to seeing how this can continue to make an impact into the marketplace.